This is Proxy. It's a remotely controlled robot that's part of a video conferencing system that I built during vacations at my parents' home in Bengaluru. And that's me at the other end of the system at my home in California. Standing in front of another robot I built, which uses artificial intelligence to translate my body postures into control signals and relays them over the internet to that robot in Bengaluru, which gives me real-time hands-free control of that robot from the other side of the planet. This was a personal project that's built using a combination of artificial intelligence, robotics, software engineering, a bit of elbow grease, and some repurposing of common household items. It was a fun and intriguing project. In this video, I'll take you through the build process. My name is Saharsh, and this is Project Proximity. I started the build with a prototype to test various aspects of the robot, things such as stability, motion control, and resilience to connectivity issues. I just had a handful of days on the vacation trip, so I worked with material I could source locally from our neighborhood or online with fast delivery. For the base of the robot, I used a 2x2 panel that's made out of a wood composite, and for the chassis, I'm using an end table I ordered from Amazon. The system has 4 wheels, 2 of which are furniture casters, and the other 2 are Arduino-driven stepper motor wheels. Stepper wheels can rotate independently at different speeds and directions. The dual motor configuration brings about a lot of maneuverability and makes it easy to do things like precisely turn in place, move forward or back at different speeds, or follow differently curved paths. I'd already tested all the software and circuits before I started filming the project. So at this point, the task was basically to assemble the parts and make sure that the wheel and the body were precisely aligned with the base. Misalignments could have had an impact on stability. Once these parts were securely attached, all that was then left to do was to make sure that the components were properly connected. With the robot fully assembled, I moved on to test various aspects of the system. The first test was basic motion control. In this test, I'm controlling the robot directly using a Bluetooth keyboard. Stepper motors allow precise control over the speed and turning radius. Steering the robot around corners and turning in tight spaces also looks pretty good at this point. The next task was to establish and test remote connectivity. I benchmarked various communication mechanisms for low latency and currently use direct TCP connection. At the time of filming, however, I was using Google Cloud's PubSub service to send the control signals. This was followed by testing the AI vision controller. It's a pose estimator that uses Movenet model running on Tensorflow. It's programmed to translate my body poses into control signals that drive the robot instead of the Bluetooth keyboard. And the final test was to route the output from the AI vision module over the cloud connection we had established earlier. I used a West Coast VPN server to simulate cross-geo network traffic and get a sense of real-world network latency. So even though I am physically in the same room as the robot, the control signal is circling the globe before it reaches and moves it. This helped me make the system a little more resilient to network issues. And with that, the prototype has passed all the tests, and it was time to make the system a little more user-friendly and practical. It was time for the overhaul. It's where the whole thing gets taken apart and then assembled back in its final form. And while that happened, let's talk about the motivation behind the AI vision controller. In its ideal state, a proxy system should allow a user to remotely control a robot without the need of a keyboard or a joystick. This is important because it can let the user be a little more immersed in the remote environment. An AI vision interface is a step in that direction, and the main goal for me was to make the system more seamless when I used it. And the fact that this was a personal project, it was a good opportunity to experiment with and learn new things. The AI vision control paradigm made the project just a little more fun and challenging. And with that said, let's get back to the overhaul. After having taken the system apart, I've shaped the baseboard, narrowing it in the process, and also made cutouts for wheels at the sides. This reduces the width of the robot, makes it easier to navigate through tight spaces. The Proxy now also has a color scheme and sports battle stripes to give it a little more of an industrial character. I used a combination of adhesive vinyl sheets, spray paint, and painter's tape to create this design aesthetic. There are multiple electronic components such as batteries, Arduinos, sensors, and wiring that conducts both AC and DC currents. The plan is to pack all of that in a bottom shelf of the robot where they'll be safely insulated. And their weight, especially that of those 2 batteries, will help lower the center of gravity, making the robot more stable. To do this, I'm building a plexiglass enclosure in the bottom shelf to encapsulate all the electronic components. I also left some gaps to keep the enclosure ventilated. I then move on to preparing spice boxes for housing these sensors. 2 of them will house ultrasonic distance sensors that will assist with collision avoidance and will be mounted at the front and rear ends of the robot. A third box will house a fisheye camera that's mounted to a mast and produces a full 360-degree video feed of the robot's surrounding to make it easier to drive remotely. And to add a final finishing touch, I've wrapped the edge of the baseboard in child-proof safety foam to absorb the impact in case of any collisions. And with that, the Proxy has reached its final version. Steering the robot seems to be easier now, and that's mostly attributed to the reduced width and inset wheels. All systems appear to be working as intended, and I got done just in time because my flight back to the US was scheduled for the day after. So I said my goodbyes and got on the 17-hour flight back to the US. After getting back, I spent a couple of weekends refining the AI vision interface. I've added visual cues to the UI so that the system provides continuous feedback on my pose. There are advantages to this feedback mechanism. The most obvious is that I won't have to constantly guess if I've got the right pose. And as with any feedback mechanism, it's a learning tool that will help build muscle memory over time. The way this control mechanism works is that extending the right arm within an angular range of the elbow activates the robot. The activation is indicated by overlays on the screen which turn green when properly activated. Then tilting my head up or down moves the robot forward and back. Rotating the head left or right turns the robot in that direction. It is the first version of control gestures, and while it definitely works, it also definitely has room for improvements. And for the purposes of this video, we've got a lightly rehearsed demo. Our cook has prepared 2 cups of masala chai and placed it on the robot's body, which is actually an end table and was totally made for this. I then take over the robot from California and drive it from the kitchen to my parents in the living room, completing what I believe is the first intercontinental chai delivery, all the while playing an unplanned game of tag with my nephew. And while these example use cases are more symbolic than anything else at this point, they do add an extra dimension to video calls with my family back home. And that brings us to the end of this video. I had a lot of fun building this project and I hope that you found it interesting. That is my Proxy, and this was Project Proximity. Thank you for watching.